Hey y'all, welcome to a new video. So recently, a lot of folks in the Laravel community have been talking about events. Jeffrey Way recently posted a video called The Intermediate Developer Trap on Laracast's channel, which is a really good video. It's not necessarily about events, but it does use events as an example. And I was already thinking about recording a video related to that to stir up some debate. And yesterday I stumbled upon an article by, look, I don't want to butcher your name, by Luke Kuzmish, called The Pitfalls of Events in Laravel Observers in Large Teams. And this is my first time doing this sort of reaction video, but I figured it'd be good for us to go through this article. I do have a different point of view than the author. I do think it's a well-written article. It does go through a lot of pain points most people go through, including myself. So yeah, I think it's just good for me to go through that blog post and share my opinion on each one of the points he mentions. So let's do this. Let me open this up here. Okay, cool. So the pitfalls of events and Laravel observers in large teams. August 18th, Luke Kuzmish. So I want to talk about one of the biggest pain points I've experienced as a developer working on a large Laravel project, model observers and events. They have introduced significant complexity and challenges on projects multiplied by the fact that at least 10 people have worked on the code base over the span of several years. Okay, that makes sense. When you introduce any sort of interaction, it could increase complexity. So he starts by talking about observers. I initially embraced the idea of event-driven design a few years back. I introduced observers into a code base which had grown from a single developer to a team of 5 over the course of 3 years. The reasons for doing that were twofold. First, I wanted to play with observers. I was excited to be learning so many things from reading these docs, step to bugging through packages to project use, and blog posts. So this goes very in line with what Jeffrey Way says in the Laracast video. When we get into the intermediate stage, and the same happened to me, we learn about all of these shiny things and new techniques, and we want to use them. And I feel that Luke is talking about the exact same thing here. Secondly, I thought I want to make it so that some action always occurs when this model gets saved, updated, deleted, without having to find all of the places in the code where we call save or update. Okay, so far it makes sense. So let's see the problems he mentions: obscurity, discoverability, and cognitive load. When I'm working on a project by myself, it's easy for me to remember that there's something happening every time I modify a model. When the team grows, features getting added or changed, the cognitive load on developers increases. They must consider the hidden side effects of model updates. This has led to things in a code like this. Okay, so you're just calling save, and you also have to let people know that you have observers being called. Changing tasks, everything's handled synchronously in our test suite. If we have 100 tasks that save a user, they will need to accommodate that newly added observer. Okay, so here's an example of a task, pretty simple. You're hitting a route, you're refreshing a user model, you're asserting something changed. And now we're adding an observer that updates a Stripe account if one exists. This task, which previously was testing simple CRUD functionality of a controller, will now also execute the observer code. And then the task might take longer and might fail because it's not using a dummy Stripe service. So we have a few options. We can call create quietly, which will not trigger events. And another option would be to fake the create Stripe profile job. But what if you later decide you need to dispatch another job inside of your observer? You have to also fake the job and do so in every task. The underlying issue is that changing an unrelated task signal a deeper problem in how well our tasks isolate and validate specific functionality. How good are my tasks if they're not isolated from out-of-process functionality? Can I be confident with them, or do I need to perform a lot of manual testing? What if I add something to the observer that doesn't cause the task to break? Have I really written a good test? Those are really good questions, and I agree with him 100% on this paragraph. Not triggered by inserts or updates. So if you're doing bulk inserts or bulk updates and you're not actually working with models, you're just working with the query builder, then the model events will not be fired. Events. I think that the push for event-driven design gets a little muddy when talking about Laravel events. This can be because event-driven architecture in a lot of languages expect the event is handled in a separate process, such as a green light thread. For instance, I dispatch an event and then an isolated thread of my application handles the event. So what he's saying here is that in most languages, or in lots of languages, what you have is events being handled by either a separate process by default, or by a separate thread or a green thread. So for example, if you're doing Erlang, you'd be passing a message that's going to be handled by a different bean process. Other events relate into a stream, which are then handled by other processes. But as we know, PHP is designed to run as a single process, receive a request, do some application logic, and then return a response. In Laravel, events are not queued, only their listeners can be queued. This allows us to dispatch an event, such as user update, and let some of the listeners run in the lifecycle of the request, while other listeners handle the event later with the queue worker. Events have all the same problem of obscurity, discoverability, cognitive load, and task and confidence that observers do. The benefit often attributed to event-driven architecture is that we can dispatch an event, and different domains can listen to the event without the tight coupling required for a single orchestrating command. This is absolutely true, but let's look at some of the other unique pain points. Okay, so I'm gonna stop here real quick and share some thoughts. So I feel like a lot of the problems described here can be scoped down to observers. And I don't think observers are usually good. They're good for simple logic like logging. That's something that you could do in an observer. But a problem with observers is the events are not really meaningful. Something like user update is really not a meaningful event. User created, not a meaningful event. And that also ties in with the way that active record works. Active record aims for a data-driven application logic instead of a behavior-driven application. And what do I mean with this? With active record, we are working with rows. We're working essentially with database rows and not business constructs, if you will. So saying user updated doesn't really tell me anything about what happened. I just know that some properties were changed on a given database row. Seeing something like payment created or payment updated, same thing. Now, if I were to get events such as order placed, or payment succeeded, or payment fail, or order shipping address changed, those are very meaningful events. They're very specific, so your application, the listeners would know exactly what to do with them. And they also give this narrative context to an application. So I think lots of the problems mentioned here, sure, we do have some infrastructure problems, which I'm going to address in a few, but a lot of this is due to the events that are being dispatched. With any active record implementation, you're doing things like this. You're updating a row on the database. Now, imagine if there was, instead of user update, what if it was disable user? What if this was a behavior-driven approach? So if we're calling a disable user method that would then dispatch a user disabled event, that's much more specific to what's happening. You would be able to fake that event specifically when testing if you wish to, and then the listeners would know exactly what happened. You give that narrative factor to the application, but let's move on. So order of operations. Does order of event handling matter to your application? How do you guarantee that the events are handled in a particular order? What if someone comes along and makes a change where event listeners are registered, so swapping out their order? How do you protect yourself against this? If all of your event listeners are queued, there is no guarantee that the events will be picked up and worked in any particular order. For example, if an event listener that sends an email runs before the listener that updates an associated database record, you might end up with email content that is inconsistent. Okay, so what he's saying here is that if you had queued event listeners, and that happens to any message-driven application, you might not be able to first guarantee that the messages are going to arrive in order. They might arrive out of order, and then how do you guarantee that your application can handle that? In most message-driven systems, you have to expect this. I wouldn't say this is a problem, but more of a characteristic of message-driven systems in general. You have to account for the fact that you might get a message out of order. The same way that you have to account for the fact that you might get a webhook with a significant delay, or you might get webhooked out of order. That also happens. So I wouldn't say this is a problem. Sure, this is a pain point, but this is more of a characteristic. I would actually say that I prefer all event listeners to be queued. all of the application event listeners. Sure, you might be listening for example, some framework events or some third-party packages events, and your application does something when those happen. So in those cases, you want them to be synchronous. But when it comes to your application events, your domain events, I would usually advocate for them to be asynchronous. So you don't want to handle them synchronously. And then you have to account for out of order events. Essentially, you don't want to create operations that depend on events coming in a given order. And then we have this last paragraph here. So if an event listener that sends an email runs before the listener that updates an associated database record, you might end up with an email that is inconsistent. So I think the problem here is I don't think that should happen at all in most scenarios. What you would usually do is you would associate an event dispatch with a state change in an atomic unit. So I don't see why a listener would update an associated database record and then another listener would send an email. What I see making sense here is you have, for example, a command or a method call, I don't know, that performs the state change on, in this case, it's active record, so a database record, and then also dispatches an event as an atomic unit. So if the state change update fails, the event is not dispatched. If the state change goes through, the event is dispatched, and then you would have a listener that sends this email. So for example, if you have a payment succeeded event being dispatched, I wouldn't dispatch the event first and then have a listener update the payment record to be set as succeeded. I would do that state change and dispatch the event together. So when the listeners pick that up, the state has already been changed and persisted, especially because you would do that within a transaction. So you can guarantee that. Let's move on. Exception handling. If your events are not queued, this is something I would not advise, and are instead happening in the lifecycle of the request, and the listener which throws an exception will break the application. Is this desired, or do you want the response to still be returned to the user? What if a failure in one of the listeners leave the database in an invalid state, such as creating one row but not child rows in another table? That's fair. That's a big problem, and that's why I would always advise application events to be asynchronous, to always be queued. Bad citizens. Objects are passed by reference. Say your event looks like this. Okay. And we're passing an object right here. It's possible that any listener which handles the event can modify the user object, leading to failures in event listeners later in the process. Again, if you're passing them as queued listeners, you won't have the problem. What to do instead? Okay, so I've given a lot of pain points. How do we minimize them? Write tasks which ensure application state. Fake your queue notifications and events by default. I agree. I think you should do this, usually. Rely on actions. The command pattern, often called actions in the Laravel system, they're kind of the same thing. Actions are really self-handling commands. You don't have a command, DTO, and then a command handler. You have them as a single thing. Are my preferred solution. I also like them very much. They are a class that is responsible for executing functionality and orchestrating other functions. Agreed. Cognitive load is reduced when we can see that. When I want to update a user, I call the update user action, which will modify a row in the user's table, and will then modify their Stripe account and modify their existing invoices. Top to bottom, the functionality is in one file. I do not need to modify my tasks because creating a user does not defer to the framework to handle out-of-process functions. I agree with a lot of this. There is one something that I do not agree with, which is update user action. Again, I think that's the same problem we have with generic events. Update user action doesn't really tell me anything about what behaviors does the application offer to an end user, or what affordances we have in our code base. What am I updating exactly? Am I updating their profile? Am I updating their address? Am I updating their password? This is very generic. And it feels to me, this usually leads, I'm not saying this is the case here, but that's usually a smell that you have very anemic domain logic. So instead of updating the user through a domain-rich way, where you would probably have a method that tells you exactly what you're doing. I'm updating the address, I'm updating the password, I'm updating something, blah, blah, blah. You defer that to an action class that is a command. And then within the command, you just calling an update on the model or just setting the properties and saving it. So you're just placing logic that will live in place A into place B. Not saying this is the case here, but it's certainly a spell. Additionally, decomposing functionality makes it easier to write tasks about components. I can focus on a single function and task that it does what it is intended to. If I only task observers indirectly, such as by calling an endpoint which updates a user and confirms that the job was dispatched, my tasks are very brittle and tied to implementation details. The more setup required to test something, the less likely I find myself actually testing every branch of that indirect function. Here's an example of how we can test update user action. Okay, we create a user, we add some invoices, we fake the Stripe service, we update something, we call the update user action, we refresh the invoices, we see that the invoice sender name changed, and then some additional things. Use jobs and batches. If functionality can be deferred, it probably should be. Push that onto the queue. If you have a volatile dependency like a third-party API, then jobs can be set to retry. If you have a series of jobs that need to run, consider using the job chain. Okay, I agree with that. Lessons learned. Observers and events can lead to brittle tasks, increase cognitive load, and unexpected behavior. Consider this carefully when employing event-driven design in your growing Laravel project. I can learn from another person reading through the code of an open source package, a blog post, etc. But it's important to think critically about its applicability to the project at hand, as well as the pitfalls. New things can be learned, but there's a cost associated with every architecture decision, which may not be mentioned or obvious in a 20-minute conference talk. The examples employed by blog posts to illustrate functionality are often divided into things like testability, discoverability, and cognitive load. It's important to remember that observers and events are not bad, but my experience has shown their benefits are outweighed by their cost. Your constraints of team size, project scope, and code architecture are different than my constraints, so I don't think this article is saying Laravel model observers are considered harmful, though I was tempted to make the title for bait. I agree. I agree a lot here. It's important to think critically about any applicability every time that you see a conference talk, including mine. You shouldn't just straight jump into the gun and start changing your code base. You should really think about that. And if you see that doesn't make sense for you, I don't think you should go through with that. Overall, I like this article. I think it's well written. I think the examples are real. Those are real problems. I've stumbled upon them. This is not one of those articles that I'm going to come and say, hey, you're actually doing this wrong. You're not supposed to do it this way. You're supposed to do it this other way. And no, that's not what I'm saying, because that's how people usually do it. That's how I started out. And that's what kind of the documentation leads you to and blog posts lead you to. So I agree. I agree with Luke here. I think those are all very real problems. But I think that the root cause is a little bit different. Regarding observers, I agree with Luke. I think observers are confusing unless you're doing sort of middleware logic, like login stuff, that sort of thing. Then yeah, observers, I don't find them very useful, to be honest. Observers such as saving can be used to ensure that you can guard against invariants in active records. So for example, that a model is always valid at the point it's being saved. That's one of the use cases I have for this, but overall, I don't really like observers. And then cognitive load. This is true. Whenever you introduce any sort of interaction, you got to be mindful of it. You have good interactions and you have bad interactions. When you introduce events, this is true. You no longer have a single class where you can see all of the steps of the code, all of the branching logic. It is now scattered amongst different places. Now, is this a disadvantage? Not necessarily. It is a characteristic because now you're also decoupled from other actors. You can have new actors tying to an event at any point, and the event dispatcher would not even be aware of this. So let's say that you have that method as mentioned earlier. Let's say that you can place an order or that you can update an order shipping address. When you're dispatching that event, order address, updated or something like that, the listeners or talking a lot. The dispatcher is not aware of the listeners. So you do solve temporal coupling, and I'm doing air quotes because you might not have had a problem to begin with. So maybe you're not solving anything. But if you're having a problem and if you want to deal with that, that is a good way because you decouple the caller from the callees. Changing tasks. I think this is more of a problem with observers. And again, this all ties into Active Record. Not saying that it's bad or not. I use Active Record daily. It's more of a characteristic. Um, since you're working with database rows and you're having some events being fired every time that you save a database row, saving a database row is not the same as business behavior. You more often than not, you have behavior that involves several rows or that involves several related models. So I don't think this is specific enough to be good in most applications. And I feel that the problem here is simply observers. Every time that you update a user, you have to deal with that Stripe listener. If you had more domain specific logic here, maybe you wouldn't have to deal with that. Again, with Active Record, you're led to that. So it's just something you have to manage. Not triggered by inserts or updates. This is true. You don't have any sort of domain logic. Those would be triggers if you're just talking to the database directly. So this could be a problem and something you should pay attention to. And then events about expecting the events to be handled in a separate process, etc. I think events, application events should always be queued. I don't see any benefit whatsoever in handling them synchronous. And if you're handling them synchronous, I would suspect that events should not be your solution there. In most cases, there are a few that that make sense, but usually maybe they're not the best solution. And then we talk about observers again. So I do feel like a lot of the problems here do come from observers. Order of operations. This is going to happen in any message-driven scenario. You're not able to expect that messages are not always going to come in the right order, at least not in most architectures. And then exception handling. So this is not what he's talking about exactly, but I think that talking about failure models is one of the most important things when you're talking about whether to go with events or not. And one of the solutions right here is to rely on actions and compose actions. So you have actions calling actions, and you always have a sort of a source of truth. You can have a parent action that does a bunch of things, including call different actions or dispatch multiple jobs. If you're calling multiple actions, you usually have a synchronous execution command. And one of the big differences between event-driven applications and synchronous applications, and we call them this way, one of the most important things I would say is the failure model. With events, you have a very different failure model. For example, think about a checkout process. Think about a complex checkout process, not at the level of Amazon, but something complex. You're taking payments. Once a payment goes through, for example, let's say that payment fails. You're dispatching a payment fail example, a payment fail event. Now you might need to update inventory. You might need to update fulfillment. You might need to update search results because that item came back into stock. If the payment succeeded, you have to deal with shipping. You have to deal maybe with giving the user some cash back. Depending on what you're selling, you might have to ask for some additional documents. So you have lots of different actions, which are even consumers in this case, that live in different domains and have different failure models. If a payment fails, that's a big problem. You cannot ship something to the user. But after the payments fail, you have different things that could fail, and they have different levels of Jesus, I'm forgetting words. Criticality would probably be a word. You have some events, some listeners that could fail, and it's not a big deal. You can retry them later, or you can have the user retry them manually later. But you have event listeners that would be critical. For example, you might have an event listener that prints out a shipping label to send the item to the user. Or you could have an event listener if you have a complex warehouse system, for example, that determines from which warehouse should items be picked up and how they should be packed, and actually tell the workers at a given warehouse what to pick for any given order. So the failure model, I would have to make a separate video just to talk about failure models, but that's one of the biggest differences that you have with event-driven. You have things being decoupled, and each listener is its own thing and lives on its own domain, and things are separate. So, for example, I'm talking about, again, let's talk about e-commerce. If the shipping label listener fails, the event consumer fails, it doesn't affect all of the other listeners that ran or that are going to run. Again, this requires a separate video, but it's something to pay attention to. So what is the conclusion here? Well, the conclusion is that I agree on a lot of things we look. Those are all valid points. Those are all real problems. I would not advise you to go with an event-driven architecture just because you read that is true. I've talked quite significantly about event-driven architectures, both in my Laracon EU talk, as well as on my Laracast course. But something I've always mentioned is be mindful of this. See if this makes sense for you. If you feel that if you feel that this is not working, and if you feel that this is over-engineered and that it's complex and you cannot understand it, then you probably shouldn't do it. One thing that I didn't talk about is discoverability. I feel this is also a symptom of not having things properly divided. So yes, you cannot go into a block of code and see everything it does, but you can use, for example, within Laravel, the event show command, which is going to show you all of the listeners that are tied to each given command. And when you have event-driven architectures, you're more often than not, you're usually not interested in the entire process. You're interested in those smaller pieces that are dispersed again between different modules. So you're usually looking at a smaller piece of the puzzle. And talking about tasks as well, I think that when you use specific events, meaningful events, small meaningful events, your application actually becomes much easier to test because you can test you can test the actor that does the state change. For example, if you're taking a payment, you can test the command that's actually taking the payment and updating state on a given payment, setting that as paid, for example. You can test that in isolation, and you can fake the event. So you just test that the state change is happening, and then you test that the event was dispatched. Then you have all of those listeners, and you can test them in isolation. You don't even need a payment in most cases. You just need the event. So you just need to hydrate that DTO, send that over, and make sure each listener does what it is supposed to. So it's I would say that anything event-driven is a big mindset shift from what we're usually doing, and I can see it not going well. And I think Luke mentions very interesting points here, very real problems. I know that I've said this several times, but it's because I see this happen quite frequently. Someone says, oh, I have this problem, and someone else comes and say, hey, you're actually doing it wrong. I don't think Luke's doing this wrong. I don't think I was doing it wrong. It's just some problems that come up with the tools we use. So yeah, just to wrap this up, I think I went through all of the points he mentions here. I don't think they're wrong. I think some things could be handled in an easier manner through different perspectives. So the first one is, as soon as you move into a behavior-driven approach instead of data-driven approach, these problems, many of them just kind of disappear as you get those more meaningful, specific events that are precise. Language preciseness is a very important thing here. You want language to be as precise as possible. User updated, order updated. I don't think those are good events usually. I think payment accepted is a good event. Payment failed is a good event. Order retried is a good event. And then, yeah, when it comes to the infrastructure side, yeah, I agree with Luke. I think things should be asynchronous if you're dealing with events. If not, you're gonna stumble upon some weird things. And with testing as well, since in real life, when you're running your application, if you have queued event listeners, they're not gonna run in the main process. And if they're doing your tasks, you might stumble upon different behavior between production and your local environment. So overall, yeah, great article. I'm going to leave it on the description. Let me know in the comments if you've had the same problems. How did you solve them? If you use events, if you don't use events, if you're 100% against events, or if you use them occasionally, and how do you structure applications? I'm interested to know how you guys do it. So again, thanks, Luke, for the article. Thanks for allowing me to go through it and sort of just give my point of view on those problems. And yeah, I'll see you guys on the next video. Bye-bye.